Right, well, we'll now move from subqueries in the from, and we've already done the where, into the select clause. Now, here we have a table with just 4 rows. These are the 4 employee numbers in the table employee, whose last name begins with the letter Y. Now, what about adding an extra column which counts the number of transactions in table transaction? Okay, so why don't you pause this video and try and work out how you do that. Right, well, here's my solution. And it looks very simple, doesn't it? Not. Here we have the number of transactions, but to do that, we needed to do a join on table transaction. We needed to do group by because we've got a count, we've got an aggregate. It's much more complicated than what we had in just these first 3 rows. So let's see if we can simplify it using this count. So first of all, what are we trying to do? We're trying to count the number of transactions from table employee. So I'll just copy that into this. And right, so that is our figure. So what we need to do is insert that as a column in our select statement. So just to remind you of the figures, we have 3, 2, 1, 2. So let's put all of that, and we have to add brackets like that. So there's 2 froms, but one of them is included in the subquery, so it looks a bit complicated. So if you do an indent or put it on one line, right, let's see what we get. And there are 2 things wrong with this. The first thing is that we are getting the total number of transaction in table transaction, the entire table. And the second is that despite the fact we've got this as, there is no column name. So what we have to do is we have to alias the derived table outside of the brackets. And this is something that I will be repeating several times, and I'll highlight each time I do. You may have heard that now 3 times. So now let's have a look at this. Right, so now we've got num transactions as the column, but it's not actually linked to the row number. It's just giving us the same figure each time. So what to do? Well, we have this table E, and we have this table T. So we need to join them without actually using a join, because this is an independent thing. So if I wanted to say that I want each row to have the total number of transactions where the employee number is 126, then we can put where t.employee number equals 126. And there we are, we have 3. So what we do instead is we change this 126 to e.table employee number. Employee number, not table employee number, just employee number. Right, let's run that. And that gets us this answer with the 3, 2, 1, 2 that we were expecting. So now let's just have another look at what we've just done. We have an inner query, which is this one here, which is based on transaction table, which we've aliased it as T. And we're saying that the T employee number is equal to the outer table employee number, the table employee. It's a bit like a chicken and egg situation now. We can't finish off this outer query without knowing the results of the inner query, and we can't do the inner query without knowing the outer query. What this is called is a correlated subquery. And what this means is that we can no longer run the inner query because it is now dependent on the outer query. If I try and just run this inner query, then we get an error saying we don't know what e.employee number is. But if you get it set up right so that the inner query just looks at a field that you've got in the outer query, then they correlate together. It substitutes in each running of this outer query the number that we get from the outer query in the inner query. So the subquery is executed repeatedly, once for each row selected by the outer query. So when we have the first row, what it's doing is saying select the count from table transaction where the employee number is equal to 126. In the second row, it's saying where it's equal to 127, 128, 129. So it links the two together without creating this formal join. And you can see that it's a lot less writing. We don't have to have this group by because there is now no aggregate. There is merely a subquery, but that's not an aggregate figure. Now, how far can we extend this? For instance, can we put the dates of the transactions in with this? So can we change that to t.date of transaction? Well, we can do it, but it won't run. So let's just have a look at that error message. Subquery returned more than one value. This is not permitted when the subquery is used as an expression. And that makes sense, because what we're trying to do is add a column, not several rows. So whatever you do with these correlated subqueries, you've got to ensure that it only returns one answer. And so the easiest way to do that is to get it to have a min, max, some sort of aggregate. So a count, as I did previously. That only returns one value. Now notice that I don't have to alias the count, because what instead I have to do is alias the table. Now, can I sum the amount? Like that. Will that work? No, only one expression can be specified in the select list when there is a subquery. There is an exception with the word exists, but it's a very slight exception. And to be honest, exists asks, does the row exist, not a column exist? So it doesn't matter with exists if you've got 1 column, 10 columns, 100 columns. It just doesn't matter. It's just asking whether the row exists. So no, you can't do that. If you want that, then you have to introduce that as a separate column. So let's do that. Select sum of amount, and we just copy the rest except for the comma, and we call that sum amount, total amount. There we go. Now it could be, if you start to do lots and lots and lots of these, that you'd be better off with the join in any case. Now before leaving this subject, there is one question I've got. These two give the same result. So if I put them both, execute them both, you can see, apart from the columns, and if I want I'll actually make the columns identical, that they come up with exactly the same number of rows, and they will, after I've done this, come up with the same number of columns. But which is better? Well, let's find out from this display estimated execution plan. And this time we can see a difference. The first query only takes 1/3 of the time, the second query takes 2/3. So using this correlated subquery can be a lot quicker than having to do the formal join. So that's interesting, because what it's doing is it's only doing the select statement on 4 transactions, not all of them. Now what happens if I reverse this? So it's doing all of the others. And I run this. First of all, I'll get the right results, but then will I get the same correlated subquery being quicker? This time they're about the same, 49% to 51%. So you can see the major time saving is made when there is less to do for the repeated subqueries. Right. Here's some questions.